Fine, good morning to everyone. This is Chakudipti of Branch Aeronautical Engineering Semester 6, bearing roll number 23951A2114. Today I am here to give a presentation on behalf of AAT Concept Video. The subject is Aircraft Systems and Controls. The topic which I have chosen is Fuel Pumps, Boost, Transfer, and Engine Driven. Now, coming to the introduction. Fuel pump systems are essential components in aircraft and propulsion systems, responsible for delivering fuel from storage tanks to the engine at the required pressure and flow rate. The efficient and reliable operations of fuel pump is critical for maintaining continuous engine performance and ensuring flight safety. Fuel pumps are generally classified into three main types based on their function and operation. They are boost pumps, transfer pumps, and engine driven pumps. Each type plays a specific role in the overall fuel systems and operates under different conditions to meet system requirements. First, coming to boost pumps. Boost pumps are typically located inside or near the fuel tanks and are primarily used to supply fuel at the positive pressure to the engine driven pump. Their main function is to prevent vapor formation and cavitation in the fuel lines, especially at high altitudes where pressure is low. Boost pumps ensure a steady and uninterrupted flow of fuel by maintaining adequate pressure in the systems. These pumps are usually electrically driven and operate continuously during critical phases of flight such as takeoff and climb. In some aircraft, boost pumps are also used as backup systems in case the engine driven pumps fails. The use of boost pumps enhances the reliability of the fuel systems by ensuring the fuel is always available at the required pressure. Then next coming to transfer pumps. Transfer pumps are used to move fuel between different tanks within the aircraft. In many aircraft, fuel is stored in multiple tanks to maintain balance and optimize weight distribution. Transfer pumps helps in transferring fuel from auxiliary or reserve tanks to the main tank from which the engine draw fuel. This process is essential for maintaining the center of gravity within acceptable limits during flight. Transfer pumps are generally electrically operated and are controlled either manually by the pilot or automatically by the fuel management system. These pumps are designed to handle relatively lower pressure compared to boost and engine driven pumps, and their primary function is fuel relocation rather than direct engine supply. They are categorized based on their functions and placements within the system as we have seen now. Understanding their operation is critical for maintaining aircraft safety and efficiency. The overview of fuel pump types. The main types include boost, transfer, engine driven pumps. Each pump type serves a specific purpose within the fuel system. Proper selection and maintenance of these pumps are vital for optimal aircraft performance. Boost pumps. As we discussed, boost pumps are electrically powered devices designed to supply fuel at higher pressure. They ensure fuel flow from the main tanks to the engine driven pumps. The primary purpose is to prevent fuel starvation during engine start or in case of low tank pressure. Boost pump operations and uses are: boost pump typically turn on during engine startup and in flight if fuel pressure drops. They helps to maintain a steady fuel supply to the engine driven pumps. In some aircraft, boost pumps can be manually controlled or automatically activated. Then coming to transfer pumps. Definition and role. Transfer pumps moves fuel between different tanks within the aircraft. They facilitate balancing fuel loads and transferring fuel to the engines. Transfer pumps are usually electrically driven and operate on demand. Transfer pump operation and control. Transfer pumps are activated to move fuel from auxiliary tanks to the main tank. They are controlled via cockpit switches or automatic systems. Proper operation even fuel distribution and prevents overload in a single tank. Engine driven pumps. Introduction. Engine driven pumps are mechanically powered directly by the aircraft engines. They provide high pressure fuel delivery necessary for engine operation. These pumps are typically located within or attached to the engines. The functionality of engine driven pumps are they draw fuel from the aircraft fuel tank and supply it under pressure to the fuel nozzles. They operate continuously when the engine is running. Their design ensures reliable fuel flow during abnormal flight conditions. The combined operation of boost, transfer, and engine driven pumps ensure a smooth and efficient fuel supply systems. Boost pumps provide the initial pressure required to the feed the system. Engine driven pumps. Transfer pumps manage fuel distribution within the aircraft, and engine driven pumps deliver fuel to the engine at the required pressure and flow rate. This coordination operation helps in maintaining engine performance and preventing fuel starvation under all flight conditions. One of the key challenges in fuel pump operation is preventing cavitation, which occurs when vapor bubbles form in the fuel due to low pressure. Cavitation can cause damage to pump components and reduce efficiency. Boost pumps play a crucial role in preventing this phenomenon by maintaining positive pressure in the fuel lines. Another important consideration is the reliability of the fuel systems, as any failure can be serious consequences. Therefore, redundancy is often incorporated with multiple pumps provided to ensure continuous operation even if one pump fails. Material selection and design are also critical in fuel pump systems. Pumps must be able to withstand varying temperature, pressure, and fuel types without degradation. They are typically made from corrosion resistant materials and are designed to minimize wear and tear. Additionally, modern fuel systems incorporate sensors and control systems to monitor fuel flow, pressure, and pump performance, allowing for real time adjustments and early detection of faults. In advanced aircraft, fuel pump systems are integrated with automated fuel management systems that optimize fuel usage and distribution. These systems reduce pilot workload and improve overall efficiency. The integration of electronic control systems also allows for better coordination between different types of pumps, ensuring smooth operations under all conditions. In conclusion, boost pumps, transfer pumps, and engine driven pumps are integral components of aircraft fuel systems, each serving a distinct and essential function. Their coordinated operation ensures reliable fuel delivery, efficient performance, and enhanced safety. Understanding the working principle and roles of these pumps is crucial for designing and maintaining effective fuel systems in the modern aircraft and propulsion systems. Comparison of pump types. Boost pumps are electric primarily for starting and backup, while engine driven pumps are mechanically linked to the engine. Transfer pumps facilitate fuel movement between tanks, ensuring balance and availability. Each pump type plays a distinct yet complementary role in aircraft fuel management, maintenance, and troubleshooting. Regular inspection of fuel pumps is vital to detect wear, leaks, and blockages. Malfunctions can lead to fuel starvation or imbalance affecting aircraft safety. Proper troubleshooting involves checking electrical connections, fuel flow, and pump operation. The safety considerations are always verify pump operation during pre flight checks. Use caution when handling electrical components to prevent spark or fires. Properly functioning fuel pumps are critical for safe aircraft operation. Then coming to conclusion. At last, I would like to terminate this presentation by saying that fuel pumps like boost, transfer, and engine driven are integral to aircraft's fuel systems. Each pump type has specific functions that support safe and efficient flight. Understanding their operation and maintenance is essential for pilots and technical alike. Boost pumps, transfer pumps, and engine driven pumps are integral components of aircraft fuel system, each serving a distinct and essential function. Their coordinated operation ensures reliable fuel delivery, efficient performance, and enhanced safety. Understanding the working principles and roles of these pumps is crucial for designing and maintaining effective fuel systems in modern aircraft and propulsion systems. Thank you. Thank you for giving this opportunity.